Now I didn't have a lot of room here to sketch the function, but here it is. If x is in this direction, y is in this direction, z in this direction. We have function value 2 here. Now let's get a little perspective. This function, f of xy equal x plus y squared, is a function in two variables. It's got a graph in three-dimensional space. And if you think about this, it's actually a quadric surface, it's a paraboloid. You can think about what the actual graph might look like. But here I've simply constructed the part of the graph that lies above the circle x squared plus y squared equals 2. This is implicitly this constraint circle, the constraint curve. So here's your constraint curve. You got this paraboloid behaving somehow. And you look at the intersection of the graph of that paraboloid with the constraint curve. Okay, with the cylinder above the constraint curve, and you get a graph that looks like this. And you should probably think about actually doing that. We use the Lagrange multipliers to find the max and min of this function, so we get an idea of what it looks like within this, above and below this circle here. Again, the intersection of the graph with the cylinder. We weren't necessarily thinking about it that way. We were just thinking about a constraint curve in some function on the constraint curve. We analyzed it and we got this information. Okay. Well, what does the graph look like? At this point, f is 2, and at this point, f is 2. Okay, well that corresponds to the intersection with the positive x-axis. I'm going to draw kind of a little red line there. This corresponds to the intersection with the negative x-axis, and that's actually kind of hidden from this perspective, so I didn't draw that. But we have a maximum at this point. Okay, that maximum, since I've got that x marked in green, I'll mark the corresponding point in green here. That maximum occurs right here. And then there's a maximum over on the other side, symmetric with respect to reflection through the x-axis, so it might be about here. So we have this minimum value, then we climb up to this maximum, then we fall to a minimum that's kind of hidden, then we rise back up to a maximum that's right here, then we fall back down to our minimum here. So there's a picture of the curve, and it was easily enough sketched just by sketching the intersection of the curve with the xy plane, and then just drawing little segments of varying length, starting from the shortest, moving up to the longest, and then shorter and shorter, all the way around. Connect the tops of those segments with a curve, and there it is, and hopefully that gives you a pretty good picture of this situation and the extrema of the function.